All right, so for our review, okay, we are going to go over all of the odds, okay? You have to do the evens. You have to have all questions done to receive credit for the review, okay? But we're going to go over all of the odds, okay? We're finished about half of it today, a little over half of it, honestly. And then you'll have some time to work on the evens tomorrow in class as well as us finishing it up, okay? So we're going to start with number 1, okay? So for this first section, we have to find the transformations and the vertex, then graph the function, okay? So we have to know our transformations for our absolute value functions. Those will not be on the board for our test. You have to know those, okay? Now, when we look at number 1, but those are like the only rules we have to know. Everything else is procedural stuff. It is a vertical shrink. Okay, that 1/2 right there causes a vertical shrink. Okay. So, it is specifically a vertical shrink by a factor of 1/2. Okay, but does a vertical shrink or a vertical stretch affect our vertex?
No.
No. So what is our vertex here? 0, 0. Okay, so our vertex is going to be at the point 0, 0. But a vertical shrink does affect the sides of the V, right? Because an absolute value is in the shape of a V, okay? The vertical shrinks affects the slopes of those sides. So whatever that number is in front, whatever our A is our shrink, okay? So we go up 1 over 2, up 1 over 2, okay? And then all of our absolute value functions have to be, starts with an S, symmetric. So we have to make the other side match. Okay? So from here, okay, that is how we graph this. Our A determines the slope of the sides of the V, okay? Now, we're going to look at number 3. So for number 3, we have a 2 in the very front. What type of transformation does that cause?
Vertical stretch.
Vertical stretch. Okay. It is specifically a vertical stretch by a factor of 2. Okay. So for this problem, does that affect our vertex?
No.
So if you remember, it does not affect where our vertex is located. So where is that at?
0, 0.
Pardon me, Ms. Williams?
Yes, ma'am.
Judge and Perron, do you have the dismissal?
Yes, ma'am.
Thank you.
Okay, so we put this point at 0, 0. Now, what is the slope of the sides of the V going to be for this one? Up 2 over 1. So draw our graph. Yes, ma'am. So a stretch is greater than 1, and a shrink is between 0 and 1. Okay, so we're going to go ahead and we're going to look at number 2. Okay, real quick. I want to go back to this one just because I want us to talk about something. So how many transformations are in the question 2? 2 separate ones, okay? That minus in the very front causes a what? A reflect across the x-axis. That's fine, yeah. So it causes a reflect across the x-axis. Then the 4, is 4 greater than 1 or between 0 and 1? Greater than 1, so that makes it a vertical stretch. Okay, neither of those things affect our vertex, so it's at 0, 0. So when we do this, okay, our slope of the sides is going to be -4. It's going to go down 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. Do what? What was that, Felipe? Does it go to the right? Wait, what?
He said he got it right.
Oh, okay. I was like, it goes to the. I'm confused. All right. So that is what happens if you have both a stretch and a reflection. Okay. You kind of think of them as two separate transformations. The negative causes something, and then the 4 causes something. Okay. Now we're gonna go to number 5. Okay, number 5. We have a transformation of +2. So we go up 2. What causes that to be a transformation of up 2 and not left 2?
Because it's not in the bracket.
So anytime our transformation is outside of our absolute value lines, okay, absolute value brackets, it makes it go up or down, okay? If it's inside, it goes left, right. So this is up 2. What does up 2 do to our vertex? So what would up 2 from 0, 0 be? 0, 2. Okay, so we go to 0, 2. Now, in this one, do we have a visible A in the very front? No. So what's understood to be there? So our slope is up 1 over 1, up 1 over 1. Then we are good to go ahead and look at number 7. And the reason there's so many of these is because I wanted us to make sure we knew how to deal with each type of transformation and combination of transformations. So that's why there's so many of these particular kinds. Okay, for number 6, or number 7, my bad. So for number 7, okay, what does that negative in the front cause? Okay, then inside of our function, we have -3. Okay, since it is inside, that causes us to move to the right 3. Okay, remember, even though that's opposite, the reason it is like that is because what number would need to be right here to make this whole thing 0? +3. +3 is on the right side. That's why it's there. Okay, so now, using our transformations, what is our vertex? 3, 0. Okay, so our vertex is at 3, 0. Now, in the very front of our function, we have that negative. That is understood to be a -1. So it's going to go down 1 over 1, just like that. As long as your arrows are on it, you are good. Because they go forever, so you just have to show that they go forever. I need at least 1 point on each side, though. Because I need to see the very defined V shape. Okay, number 9. Okay, for number 9. Okay, what does the +2 cause to happen?
Go to the right. No, go to the left.
Left 2.
I forgot.
Because it is inside, okay? And then what does the -3 cause to happen? Down 3. So if we think about how that affects our vertex, what would to the left 3 cause to do to our vertex, or the left 2 cause to happen to our vertex? What would down 3 cause? So -2, -3. And if you are struggling to think of what the point would be, start at the origin and just do whatever the transformations are. So like go left 2, down 3, and write the coordinates of that point. If you are struggling to think of what the coordinates would be, just follow the transformations from 0, 0. Okay, now, What is understood to be in the very front of this function? 1. So it's up 1 over 1.
Oh no, I did it wrong.
Whoa.
Put it negative.
All right, number 11. What does the 1/2 in the very front cause? Vertical shrink. Okay, what about the -3?
Plus, when you go to the right.
Right.
Mm-hmm. And what about +1?
Up 1. So it's up 1 over 2.
So what is the vertex?
3, 1.
3, 1. Okay, so we go to the point 3, 1. And then what does the slope of each side need to be?
1/2.
So up 1 over 2. Then make the other side symmetric. Okay, that is us graphing our absolute value functions. We can do that. We got it.
Pretty easy.
I just need to look at it.
Okay, now the next section we're going to evaluate piecewise functions. Okay, so when we evaluate, that means we are plugging in something. Okay, so whenever we evaluate piecewise functions, step 1 is to figure out which piece we need to plug into. Okay, so for number 13, we have two functions in f of x. We have f of x is equal to 3 when x is less than or equal to 0. And we have 2 when x is greater than 0. So if we look at f of 2, okay, is 2 less than or equal to 0? No, so we will not plug into that equation. Is 2 greater than 0? Yes. So what is f of 2 equal to? 2. Is there anything for me to plug in for this one? No. Okay. Now, for f of -4, is -4 less than or equal to 0? So that's the equation I plug into. What is f of 4 going to equal? Or f3. Okay. Then we have f of 0. Which equation do I need to plug this into?
The first one.
The first one. So what is f of 0? Okay. Then we have f of 1/2. Which one does 1/2 fit in? The second one. So f of 1/2 equals 2. Okay. Because it's bigger than 0. Because 1/2 is more than 0.
Oh yeah. I keep seeing that.
So essentially all we do is we just put this in the place of whatever's right here. And if it's true, that's the equation we use. And if it's not true, it's not. All right. Now, we are going to do 16 together. 16, okay? Because I want to do one with 3 pieces with you.
That's fine.
All right. For 16, okay, we have f of x. Okay, so in f of x, we have x plus 5 if x is less than or equal to 3. We have 2x minus 1 if x is greater than 3 and less than 6. And we have 3 if x is greater than or equal to 6. Okay, so first, f of 7. That we use the third equation. So it equals 3. Because 7 is greater than or equal to 6. Okay, now for the second equation, we have f of 4. Which one do I use for that? The second one, okay? Because is 4 less than or equal to 3? No. Is 4 between 3 and 6? Yes. So we're going to plug into the second equation. So we have 2x minus 1. What am I plugging in for x for this problem? So what is 2 times 4? What is 8 minus 1? There we go. Now, for C and D, I misnamed those. Those should both be F. That was just my bad. Now, for F of negative 1, okay, is negative 1 less than or equal to 3? Yeah. So we're going to plug into that first equation. So we have x plus 5. But what are we plugging in for x? So it is 4. Lois. Oh, okay. Oh, okay. It's just a different name. I didn't know what you were talking about. Y'all were really smiley, so I was like, wait, that doesn't look like a math conversation. I'm not used to the math conversations being super smiley. Okay, for f of 3, is 3 less than or equal to 3? Yes. So we're going to use that first equation. Is equal to x plus 5. But what do we need to plug in for x? What is 3 plus 5? There we go. Okay. Now, we are going to look at graphing piecewise functions. We are going to graph each piece. Remember, you need a good eraser for these. So my format is slightly off, so let me fix that real quick so that we can look at it. Okay, so for graphing piecewise function, our first question is number 17. Okay, we have two pieces here. Okay, so our first piece is x minus 4 when x is less than or equal to 1. Our second piece is 2x when x is greater than 1. Okay, something that you can use to help you know where to draw the lines. Okay, if it is less than, that's left. Less than, left, LL. Okay, if you say greater than, it's right. What's the second letter in great? R. Okay? Right. Think like Tony the Tiger. Great. Really emphasize the R because it goes right. Okay? Super silly, but it might help you. Okay? So for our first problem here, we have x minus 4. What is our y-intercept of that?
4.
Negative 4. And what's our slope? 1. So it goes up 1 over 1. Now, I have a question. Right here, this is x is less than or equal to 1. So do I need to do a bunch of points this way?
No, you just
No. Okay. And from 1, do I need to go to the right or to the left? To the left. And for this one, will it be open or closed circle? Closed. Okay, remember, when it is less than or equal to, greater than or equal to, it is closed circle. You also use brackets. If it is less than or greater than, it is open circle. Okay. Now, we're going to look at the second one here. It is 2x. What is the y-intercept there? 0. Nothing is being added. What's the numerical equivalent of nothing? 0. What's the slope of that line? So 2 over 1. Greater. So we go to the right of 1. So we'll erase any piece we don't need. And will that get an open or closed circle? Open.
How do you get it? How do you get 0, 0?
So the origin is that's our y-intercept, right? But we go up 2 over 1. And this line doesn't start till x is greater than 1. So at 1, we draw our line. Yep.
What about, let's say,
Yes.
I'll put these on the first. I mean,
Okay, what about it?
got the top.
So on the first line, our y-intercept is -4. And then our slope is 1 over 1. So we go up 1 over 1. Because it's less than or equal to 1, it doesn't make any sense for us to put a bunch of points going that way. Because those numbers are all greater than 1. So we just put a few, and then we go to the left of 1.
So what did you say about the negative?
That's our y-intercept. Because we're just graphing lines like we do y equals mx plus b.
Okay.
All right, now, number 19. Okay, for number 19. Okay, whenever we have just a constant, so it is -3 when x is less than or equal to 4. Okay, that right there is the same as us having y equals -3. What kind of line is that? It is horizontal. Okay, so anytime it puts just a constant inside our piecewise function, that is a horizontal line. Okay, so when we have that, it is going to be -3 when x is less than or equal to 0. Okay, so we're going to put a horizontal line at -3. Okay, and we're going to draw it when x is less than or equal to 0. Open or close circle. So that is our first piece of this function.
Oh, that is the most beautiful straight line I've ever seen. And I made it without.
Look at you. Okay. Our next piece is 1/2 x minus 3 when x is greater than 0. Okay. So for this one, what is our y-intercept? -3. Okay. What is our slope? Up 1 over 2. And this is when x is greater than 0. So do I need to go to the right or to the left of 0? And will this one have an open or closed circle? Okay, so essentially what is happening here is I have a open circle around a closed circle. So that's just a point. As long as you have a point there, you're good. Yes. If you need to, write down your slope-intercept form at the top of your paper and do y equals mx plus b. And remind yourself that that's your y-intercept and that's your slope. That might help. Yes, ma'am.
How do you know if it's a horizontal line again?
So if it's just the constant, because that would be like having y equals -3, which is our horizontal line. Yes. All right. Now we're going to look at number 21. 21 is a 3-piece function. Right? So it means the same thing. I just wrote it differently. Okay. So for 21, we have x plus 1 when x is less than 0. So what is our y-intercept there? 1. What's our slope? 1 over 1. Okay. I have to do x is less than 0. Does it make sense for me to do a bunch of points on this side? No. So I need to put some points going the other way. And then from 0, does it need to go to the right or left? Left, because it is x is less than 0. Open or close circle?
Okay. Does the F matter?
The if does not matter. It's the same thing. It's just I wrote it differently on accident. I wasn't paying attention. Because you can do it either way.
I was thinking of the exclamation mark they have to
All right, now we have the next piece. So negative x plus 1 if x is between 0 and 2.
I got you.
What is our y-intercept there?
A plus
1. What is our slope?
-1.
-1. Okay, so this is between 0 and 2. So I need to go down 1 over 1, down 1 over 1. Do I need to bother going past 2? No. And we connect our lines. At 0, will that be an open or closed circle? And at 2, is that open or closed?
Oh, never mind, it stops. Why are you going that way?
Okay, because it goes from 0 to 2. Yep.
Oh,
So x is literally just going to be between 0 and 2. So we do our line and we continue it until it gets to 2 and then we stop.
What about the first one? X is less than 0.
So that's why we go to the left. That's where we get this part.
It kind of looks like a clock.
Okay, now, so for this piece here, at 0, that middle piece needs to have a closed dot, but at 2, it needs to be open. Okay, now we can move on to our third piece. So for the third piece, we have x minus 1 if x is greater than 2. What is our y-intercept there? Negative 1. What's our slope there?
2? Or, oops, sorry, 1.
1 over 1. Okay? Where does this line need to start? At what x value? At 2. And is it going to go to the right or to the left of 2? Because it is greater than. Okay? And will that be an open or closed circle? And we erase any points we don't need. And that is what our graph should look like.
Mine takes a little long. Never mind. This is a weird looking graph. There's got lines everywhere.
Okay? So, we are going to stop working all of the ones together here today. That gives us a little bit of time to work on any of the odd questions and ask questions if you need it. We're going to pick up with our word problems and step functions tomorrow.